I am very happy to join you as well. So let me just share my screen. You know how with these things, it gets a little hairy sometimes, if you know what I mean. Okay. So before I get to my content, I just want to describe to you what we will be talking about. So if you joined the webinar through the social media promotion, what was shared on maybe LinkedIn, uh, the the core or the focus of the talk was always going to be AI agents, building AI agents and deploying them. But since Vlad is not here, who would be talking about the models in depth, I'm really teeing him off, in a way, because for the follow-up session, he will be doing a deep dive, and I'm going to be doing a little bit of the introduction, high level, and plus the deployment and securing aspect of it. So I hope that's fine. This is still a very technical session. So, not to scare anybody, but I will be going through lines of code. But I'll promise it won't be very intimidating or scary or even boring. I'll try to make it really light and easy to follow. Okay. So, with that, let me just go to my screen now. So, the title of this session for the next 30 minutes or so is called Build and Deploy AI agents securely and quickly with Google ADK and GitLab. So a little bit of introduction of myself. So I'm Regnard Raquedan, a senior ecosystem solutions architect at GitLab. I'm based in Toronto, in Canada, originally from the Philippines, but Toronto's my home, and I live in Toronto with my wife and 4 daughters. It's a fun house now. Um, I'm also a GDE. GDE is like a Google Developer Expert. So imagine it's Google's way of engaging with the broader developer community and people who are interested in, thinking of and talking about these creative solutions with the Google technologies. We kind of do it in our spare time. So all that to say, I'm very the things that I'll be talking about today is something that I'm very passionate about, and I also do it in my day job. So I hope that you'll see that shining through when I talk about AI agents and GitLab. Now, as I had mentioned, there'll be two parts. It's like we're splitting this webinar in my half hour in two. The first part, we will be talking about AI agents, right? AI agents, and hopefully this will give you a good baseline understanding of AI agents and how they work, right? I mean, now, if you followed a lot of the technical content these days, it's all about agentic AI, AI-based development, or AI-based agents, right? So we will talk about that and look at it from I'd say a very specific perspective, which is, looking at it from an ADK perspective. And then the latter half of the session, I'll walk you through how you'll deploy these AI agents securely and efficiently, because, you'll see that the whole system and architecture of AI agents is not too different from deploying, your, cloud native workloads, for example. There's still a lot of similarities there, and we'll try to leverage and use more of what we already know, and then deploy them um, to our desired cloud or non-cloud destination. Okay, so let's talk about AI agents. Now, for this first part, I'll be using a deck from my GDE. Let's say I'm switching modes. I'm wearing my GDE toolkit. Now, this is very nice because it's very visual. It avoids being very boring and dry. But at the same time, I like it because it explains the essence of AI agents wonderfully. Even if you're a beginner of sorts, you'll be able to at least have some working knowledge and understanding of what an AI agent is, right? So, what are AI agents? Because is it something that, it's something that's mystical, something that's mysterious? Like, what are they? Now, at the heart of it, AI agents, or agents in this context, well, just for simplicity, they're really just software, like an application, a series of code. Oh, there's an application that will respond to a system prompt, a prompt that could be generated by humans or created by humans, or a system, another system. Maybe it could be another agent. So these agents will then take these prompts and act accordingly, right? So this is still software. This is still lines of code. So imagine, um, if you've seen an AI agent source code, imagine a Python based application or code or program mixed in with system prompts or just prompts, right? So the prompt engineering of last year really became, in my opinion, AI agent development, right? So that's probably one opinion that you'll hear from me today. Now, other things that makes an agent an agent. So it needs a model, right? It needs something that will help with its reasoning. It will give it the ability to handle input and recommend the corresponding output. So imagine it's like the brain of the agent. So imagine you're building really a robot, a virtual robot, where you need the logic, the ability to reason. That is where the model will come in. And then finally would be the tools. The tools are like the what makes the agent useful. It gives them the ability to access external systems, data, and do more things. Really, because imagine you create a robot and you just create it in an empty room, right? It's not really useful. It can do a lot of things like move its arms and legs and spin around, but if it's not interacting with anything other than itself or its own environment, the utility is really almost nothing, really. So tools are what make agents useful and valuable, in my opinion, right? Because you have all of these three together, you will see how the brain, the agent itself, the code that will orchestrate that, and then the tools that, things that it can do and access will make the agent useful, right? So again, this is what we're doing when we say AI agent development or creating an AI agent. Now, why build this? Today, AI agent development is very critical because it gives your workloads and applications the ability to be flexible. When I describe AI agent source code as code mixed with prompts, it's really the whole aspect of responding to natural human language when it comes to, instead of creating like a very complicated direct set of directions, you're just, giving them how you would ask a person, right? It is more, and what it is described as outcome driven rather than path driven, right? They would be more interested in finding out what outcome they would going for, instead of you telling them go to A, B, C, and D, then generate the output, right? They're more interested in the output. The other piece with agents, they're easy with the tools available. They're relatively easy to integrate and put together, right? Prototyping with AI agents is really useful, and that really, um, when you say getting to value, if you hear that phrase, this is really it. Because, like I said, if the AI is not interacting with anything like your data, your existing systems, it's not really super useful. It's actually almost a waste of resources. And again, in my opinion. So really, we kind of need to shorten the time it takes your AI projects to value. And then finally, the AI agents can be autonomous in many ways. It can be triggered by other agents, dates, automations, and such. So it has the power really to make your life easier, and more efficient. Now, how do we build this? How do we create this using the tools at our disposal? Since I am talking about Google and Google ADK, we have to focus our attention. I guess my talk will be focusing on developing or designing agents using Agent Development Kit, or ADK. So ADK is this um, SDK, or developer kit, developed by Google, that makes it easier for developers and engineers to create these AI-based applications. Now, you can see from this slide, it's very comprehensive. The first three layers talk about what makes available for folks, like the agents themselves, tools, we'd orchestrate callbacks, bidirectional streaming, session management, evaluation, and lots of good stuff. Even the artifact management and memory to provide context to your not really context, but a way to keep track of changes in your AI-based application. And then in the lower layers, you have your debugging, tracing, and access to the models themselves. It makes it easier. So before, maybe last year, if you wanted to make an AI-based application, you really had to create almost all of these from scratch. Again, not efficient, not a fun use of your time. But with ADK, they're available out of the box. So that's why, as a GDE myself and somebody who's working at GitLab and Google Cloud, every day, I almost always tell people to look at these types of frameworks or development kits if you are serious about, um, creating a valuable AI project. The days of exploring, I think, it's still there, but the market, their higher ups are expecting more. And I'm sure you've seen that study from MIT weeks ago that they say 95% of AI projects don't deliver value. I wager that it's extreme, but I would say there's a huge chunk of AI projects out there that just remain, exploratory in nature. But if we are serious about getting faster to value, and not be part of the 95%, as the MIT report suggested, but part of the 5%, you really have to look for the tools and systems out there that will, um, make your lives more efficient and faster and more successful. So in ADK and among other tools will help you get to that valuable state, again, in my opinion. Okay, so let's now look at that architecture that we described earlier and see how it looks like in the Google/ADK world. So you have your agent, and it's going to be developed using ADK. It's going to be coded, or at least using some of the components of the ADK framework, and you're good to go. Now, the next question is the model. What model will we add to this agent so it'll be able to reason and provide inputs and outputs? That will be Gemini. So Google makes access to Gemini very easy with ADK. Again, ADK can use any model. It doesn't have to be Gemini, but from making it available and making it easy, I mean, it's really obvious that Google will make it easier to access Gemini from ADK more easy than other um, um, models, right? Now, Gemini 2.5, if you look at the documentations, it's in GA, generally available, and it's version 2.5. There are three main, you could say, flavors or types. Gemini 2.5 Flash, 2.5 Flashlight, and 2.5 Pro. So if you're using your Google Cloud Project or Gemini instance, or the services from your accounts, most likely you will be picking one of these as your model for your agent. Okay, and then the next part would be the tools. Now, these are the tools that make your agent available. Now, ADK, as I had mentioned, is very flexible, it's very powerful, and it can make, it has the ability to connect to other data sources, APIs, and other systems like GitLab to make your agent work. Okay, so again, so that's the part where I stop and talking about building AI agents, right? Because as you've seen, to summarize, to build an agent, you need to code the agent itself. You need to attach or link it to a model, right? In this case, it's Gemini. And then to make it really valuable and useful, you need to make it accessing at the same time, making other systems available for the agent. Now, how does this work? In a very quickly, when a user works with an agent, they provide the prompt. See step number 1 there on the left. Then this prompt will then be passed to the model. The model will do its work, and from there, it'll tell the agent, hey, use model or tool B to get the job done. So it's really called function calling. And then it'll pass it back. The agent will then call the Model 3 from the set of tools that we've defined. So there's a mechanism for the model to tell agent to call tool B in this scenario. And then the agent then passes it back to the user, right? Based on the agent's response. So the model will then take the response from the tool and then pass it back to the agent. So it's not apparent here, but it's described in step 4. So the whole we call this interaction among the agent model and the tools are well encapsulated here and simplified in a very simplified manner. So I hope that it makes sense why you need your agent, your model, and then your tools, right? Tools include your Google Cloud Workspace, your GitLab instance, could be your, I don't know, workspace emails, other source code providers, databases, and the like, or even other source code and even other agents, right? So this is the beauty really of ADK. So yeah, now as I had mentioned, ADK, it's really agnostic in so many ways. It can make your lives easier by accessing Google Cloud services like Google Search, but you're not really constrained by these, right? So that's the nice thing about it, because you can use LangGraph, LangChain to build your AI agent. And okay, so I will pause here for a bit because we're kind of now shifting our sites to deployment, because creating an agent is good, right? Creating an agent is good. It's fun. It's creative. You create lots of cool stuff. You sometimes the agent, the model will provide you with very interesting responses, and seeing things autonomously work, has a certain level of creates, at least for me, creates a sense of satisfaction and delight. Now, but the thing is, after building an agent, now what? Like, how do I make it work? Like, how do I make it more available? Because as I had said earlier, if your app really just sits in a development environment or in some place where it's not really useful, it's not really valuable, right? Like, even making your AI app available to your users, to your customers, that is when the value really shoots up and goes up exponentially. So you have to deploy your AI agent to a place where it can generate value for you and your company, your organization, your team, and for the rest of the world, pretty much. So we kind of need to make sure the deployment is smooth, easy, and secure, really. Because there's so many, you'll be surprised, many financial services companies right now are looking at AI agents. Like, how would AI fit in the very I wouldn't say rigid, but very tight compliance environments. You might see a lot of government entities with their own software teams deploying applications that are um, enabled by AI, right? So how do we make sure that the AI will behave accordingly as to specifications, right? So we need to deploy them to a place where it's secure and um, safe for both us and the agents. So there are really three places where, in my opinion, where you could put this AI agent workload. So either you put them in agent services that are cloud-based. So that includes Vertex AI, for example, or Agent Engine in Google Cloud. It could be in other cloud providers like AWS, mentioning them already, Microsoft. They already have similar services, and you can put them you can put them there if your organization supports them. Other places where you can put them would be serverless or container-based services. So since the applications AI agents are still code, you can deploy them in cloud native environments and then have them interact with the models accordingly. So in the demo that I'll be showing you later, I'll be using a container-based approach to create the agent and then deploy them to Cloud Run, which is Google Cloud's managed container-based serverless setting. And finally, you can put them in a Kubernetes cluster if you really, if you want the scalability. You can put them in there, which could be cloud-based, on-prem, or whatever, right? So these are some of the, I guess, easy ways we can make your agents available to your customers, users, right? And the way things are made more efficient is if you're using a DevOps approach to deploying your AI agents. So for those who have not really heard of the term DevOps, it's really developer operations. It's really operationalizing and automating the deployment and integration of your software to your of the software, and then deploying them to your desired destinations and delivering them to your intended audience, right? Now, I'll go through these quickly, but at the heart of it is you should really think about using a DevOps approach to your deployment because it's efficient. Like you're already using AI to to automate so much things. Like why why skip why skip that part in the deployment? Using a DevOps approach can make your lives efficient. Reducing all of those integration points is really a good benefit for DevOps. Obviously, security is key. You can link your security tools to your DevOps pipeline, and then you're not really um, skipping this. You are actually sometimes making it part of your default deployment workflow. And speaking of workflow, you can orchestrate. Sometimes you need to deploy to pre-production environments and then deploy before you deploy to your production environments or the environments where your customers and users will be seeing. And of course, many tools out there like GitLab can enable collaboration if you're working in an agile fashion. Uh, you know, Putting things in a Kanban board or an issue tracker or or epics, like program level planning. You can put that in there to make your lives really, again, easier for both you and your team and your organization. And finally, many tools out there are now powered by AI itself, right? So imagine really using AI to create AI agents that will invoke and use other AI tools. So again, you'll see that the role, again, this is my opinion, the role of people in this AI agent world, it's starting to, I would say, move away from the actual creation of the lines of code, but you're really more as a manager, a steward, and planner of how these AI agents will act and behave, because somebody has to make sure AI, there's quality, right? Somebody has to make sure that's compliant to whatever industry you're a part of. Somebody has to create the templates for these AI agents when you mass produce them and create AI fleets. So your role as a data person, a data engineer, will fundamentally shift in so many ways, because AI will be taking away the heavy lifting, but you kind of are shifting towards a more stewardship, management, and uh, yeah, I would say that would be the best place to describe it, in my opinion, right? Okay, now let's do a quick demo of this deployment to make sure that I am not gonna have some issues. I'll be doing a pre-made demo, but then I'll give you a chance, folks, to answer questions later. So let me just shift my sharing to GitLab. Oh, wait. I just want to make sure. Okay, I still have some content I want to share here. Okay, to give you a bit of context of what I'm trying to do, since I'm based in Toronto, I'm creating this agent, a multi-agent application that's that can ask, or that can tell people if they're interested in moving to Canada, where can you move to, right? Not that I'm recommending this; it's really just an educational project. But this multi-agent tool, this it relies on a root agent called Canada City Advisor, and then the tools that are available to it are two main things. One is a budget, a spreadsheet, CSV file of cost of living for different Canadian cities, and then the other tool is access to weather data via an API. So from a architecture standpoint, I separated the budget analysis to a sub agent, and then the lifestyle matcher to another agent. It's really weather and then money, right? Because it's Canada. Not to scare you, but if you're doing this demo, when you're since we're deploying to Cloud Run, you need a little bit of extra things to make it work, because you're kind of making this AI agent, we have to give it an endpoint to make it accessible via Cloud Run. So we're using a Python script that is making it like an API of sorts, using Fast API. And then we're using Docker to create the container image, and then we deploy to Cloud Run. The deployment architecture is very straightforward. Once your source code is committed to GitLab and scanned, and then the industry-leading CI/CD will then orchestrate and deploy to Artifact Registry. There is a native integration between these two platforms. And then once that is complete, it's then deployed to Cloud Run, right? After all the testing and making sure it's secure, and then it's made available to the users. Now, a few prerequisites: make sure that these are enabled in your project, like your Cloud Run APIs, Artifact Registry APIs, and Vertex AI API are enabled. And then your GitLab project, of course. And the high-level steps, again, to simplify things, you just need to set up the IAM integration. It's really linking GitLab and Google Cloud together. The other piece, second step, is the setting up of the artifact registry. So the artifacts that GitLab will create, the container images, will then be shipped and packaged to artifact registry, which is in Google Cloud. And it's made possible because of the prior step that we had made, which is setting up the permissions. And then we create the CI/CD. Again, I'm not going to bore you with the pipeline development, but I'll just describe to you the pipeline. And then finally, we will deploy. So that is the flow. So let me now go to GitLab. So the 4 steps that we will be doing is very straightforward. Because of the integration, it's almost really clicking a few steps. The first step is to integrate the IAM, or the permissions. So this is it. I just need to provide the Google Cloud project number, the project ID, and then some workload identity federation pool IDs in there. And then once that's run, or once that is provided, GitLab will provide you with a script that you'll run on your cloud shell on Google Cloud. Okay, pretty straightforward. Once that is complete and run, you'll then use this Google Cloud, this native artifact management, artifact registry integration between the two. Same thing, I just need to create the artifact registry repository beforehand, tell GitLab that this is where the artifacts are going to go, and then run another script on your Cloud Shell. And then these two will be integrated. Now, the next piece is the pipeline. So for DevOps folks out there, this one is for you, for platform engineers. So the pipeline is very straightforward. Again, I'm not going to bore you with the source code of the pipeline, but what I will tell you is that this pipeline, this YAML file, defines 4 main steps: a build stage, a test stage, an upload stage, and deploy. And I'll describe to you each step. The build stage is where Docker will build that container image based on the Python app that we were using for the agent. Once that is built, there's a stage that will test and secure that Python application, that container. GitLab has several default security scanners that are included for free, so you don't need to pay for extra security services. You just call them in there. The third step and penultimate step is the upload, where that secured container image is then shipped to artifact registry. And finally, with deploy, the pipeline will orchestrate the deployment of that specific container image all the way to Cloud Run, right? That's the highlighted piece right here. So after all that is done, I'll show you the pipeline, which I had created before. So it passed. So these are the build stage, the stage that I had described: the build, testing, upload, and deployment. And you'll see the logs here when I deploy that it was a successful deployment after a lot of these operations. And yeah, so this is and now you'll see the agent right here. So this is a Cloud Run based application, and now see it's live. So we can now interact with it and ask it, I like warm weather. Where should I live? So yeah, again, this is a there you go. There's there's like many tech demos. It seems like the API is not ready, but the agent tried to access the tool, so all good. Okay, so I will stop sharing this, but do know the deployment was successful and our agent was all good. Okay, so with that, let me go back here. Now I'm opening the floor now for questions. So yeah.